Okay, good morning everybody. Today we are looking at 1.8.1, solving inequality notes, and there will be an exit ticket for practice. So let's go ahead and dive right in. Inequalities. You've looked at them before a little bit, but today we're really going to learn how to solve them and look through them. But the first thing you need to know is, what are the inequality symbols? There are 5 of them. So if you can, try to pause the video real quick and write down and name as many as you possibly can. Okay, hopefully you pause that video. So we're going to go with the first one, which is usually the easiest. This is the equal sign, right? So this tells you whether it's two sides, one on the left, one on the right, are equal. Second one is greater than. Okay, so greater than typically faces to the right. Okay, greater than or equal to. So this means that you have a number that it's bigger than, or it could be equal to as well. Greater than or equal to. And so then the last two, of course, are less than and less than or equal to. Okay, so those are your 5 inequality symbols. So let's take a look here. Determine if the value is a solution, for which of the inequalities is x equal to 0 a solution. How do you know? All right, so what we're going to do is we're going to actually look at these inequalities, and we're going to take 0 and plug it in for that x variable, because that's what it says it's equal to. So instead of this being x, we're going to say 0, and we're asking the question, is 0 bigger than 2? So you really need to know what inequality symbols mean what. So remember that the alligator mouth opens up to the bigger number, right? So if the alligator mouth opens up to the left in this one, is 0 really bigger than 2? No, right? It's absolutely not. So this is not true, not a solution. Okay, so 0 will be a solution if we plug it in and it produces a true statement. All right, so number 2, is 0 less than 0? No, still not true. They're the exact same number, right? So it's not a solution to this inequality either. Okay, how about number 3? 0 does not equal 5. Well, that's true. So it is a solution. Okay, and I actually messed up here. I meant to say inequality. So this is the we'll say it's not equal to. I mean, you have the equal sign, obviously, but I think most people are unfamiliar with the not equal to. Okay, how about 0 is less than or equal to -3? Is that true? So think about -3 on the number line, right? You have -3, -2, -1, 0. Okay, is 0 smaller than -3? No, so this is not a solution either. Okay, now we have an inequality that looks kind of like an equation, so we're going to plug in 0, and then we're going to solve it. 3 times 0 is 0. 0 minus 2 is greater than or equal to 5, so -2 is greater than or equal to 5. Also not true, right? So it's not a solution. Okay, so just kind of plug it in when it says whether it's a solution or not. It just needs to make a true statement. That's all. All right, so now we're going to take a look at inequalities in terms of a line a graph, a number line. Use these graphs to determine inequalities that have x equals -1 as a solution. How do you know? Okay, so when you're looking at a number line, remember that this is open, and it means not included. Okay, and this is closed, which is included. Okay, so I like to think of it because sometimes you'll see it, they'll mark it as like this. They'll put a parenthesis there instead, or they might put a bracket there. So a bracket to me always reminds me of like a box, right? Like if you're gonna move, you're gonna put the things in the box that you want included that you're gonna take with you, right? But if you have like a bouncy ball or something that has like a rounded edge, you can't put anything in there, or even a bubble. Let's say it was a bubble. Let's say you're blowing bubbles. You cannot put anything in the bubble once that bubble is blown, right? Because then it would just mess it up, destroy the bubble. So it's kind of the same thing here. So we have an open circle or a parenthesis means the same, or a bracket is the same as a closed circle. They're closed, and they are included, or open and not included. So in this one, we have a closed circle, which means -1 is included, and it is on the number line, so this is a solution. -1, because that's what it says, x equals -1, so this is a solution. All right, how about this one? -1 is over here. If you draw a line straight up, it is on the number line, so this is also a solution. Okay, and then lastly over here, we have this number 1. We draw a line straight up. It gives us an open circle, so even though it touches -1, we said down here, open, it is not included on that circle. So this is not a solution. Okay. So let's review solving linear inequalities. Place inequality symbols, so you're not allowed to use the not equal to, between each of the sets of the following numbers so that the statement is true. Okay, so we have -2 and 12. -2 and 12. So -2 is smaller than 12. You could also say it's smaller than or equal to, right? Okay, 8 and 4. We could say greater than or equal to. -3 and -9. Ooh, be careful. This is a bigger number, but it's further away from 0, right? Further away. So this is bigger than -9. And you can say greater than or equal to, or just greater than. Okay. Now, using the inequality from part A above, perform the following operations to both sides of the inequality and then rewrite the new statement. So we want to add 2 to both sides. So -2 plus 2 and plus 2 gives us 0. 0 is less than 14. Still true. Okay, how about subtracting by 2? Okay, so -2 minus 2 and 12 minus 2 gives you -4. -4 is still less than 10, so that one's okay. All right, this one is multiplied by 2. So multiply by 2, multiply by 2. -4 is less than 24. Still true, we're still okay. Divide by 2. -1 is less than 6. Still true, 6 is bigger than -1. Okay, multiply by -2. All right, -2, -2. -2 times -2 is a +4. It says less than, and 12 times -2 is -24. Okay, so we're true, right? Just kidding. So since 24 is smaller, that means we need to rewrite this. This would be the opposite way. Look, it goes the other way now. Okay, so notice that when we multiply by negative, okay, flips the sign. How about when we divide by negative? Because this is divide by -2. Okay, -2 divided by -2 is a +1. 12 divided by -2 is -6. Is 1 less than 6? -6. It is not. Okay, so when we divide, we also divide by a negative. We also flip the sign. Okay, so what did you observe? The inequality sign flips when we multiply or divide. This is huge. You need to know this. This is the biggest mistake in this section by students. Multiply or divide by a negative number. Okay, so a couple more examples here. Solve these inequalities and then graph the solution on the number line. So let me give you a little piece of advice. If the x is on the left, you follow the direction of the arrow. If the x is on the right, okay, and it says like this, it is the opposite. Okay, so 2x and 11 divide by 2. It's +2, so we do not have to flip the sign. This gives us x is less than 5.5. X is on the left, it points this direction. So now also notice that it's this, right? So if it's this symbol, then it's open circle. If it's with the line, it's closed. Okay, so like we talked about up here. All right, open and closed. So I always say, if you take the time to draw the line underneath the less than or greater than symbol, then you should take the time to fill in the circle as well. So -5.5 is here. The line's going to go this way, and it is open because there is no line underneath. Okay? All right, let's go ahead and move on. So in this one, we're going to add 5 halves. So if I have 1 half and I add 5 more halves, I now have 6 halves. And 6 divided by 2 is 3. Okay? And now I'm going to multiply by 3 over 1 by the reciprocal because we had a fraction on that side. And so now I have x is greater than 9. We do not have to flip the sign because we multiply by a positive. So x is greater than 9. We go to 9. It's an open circle because we did not draw a line underneath. And it's bigger than. Again, follow the direction of x as long as x is on the left side. So same thing here. I'm going to move this x to this side because I do not want my x's on the right. All right, so 2/3 and 1/2. They have to have same denominators. Okay, so let's change that. So 3 and 2 have a common multiple of 6. So in order to go from 3 to 6, I have to multiply by 2. So that would give me 4/6. And 1/2 would change to 3/6. Okay, plus 1 is greater than or equal to 0. Okay, so 4 minus 3 is 1, so this is 1/6 x plus 1, which is greater than or equal to 0. Okay, and I'm going to move this up here. All right, so now we're going to subtract that 1, so 1/6 x minus 1 from both sides is greater than or equal to -1. And then I'm going to multiply by the reciprocal, so 6 over 1, 6 over 1. So x is greater than or equal to -6. Again, I multiply by a positive, so I do not have to change the sign. -6. It's a closed circle because it has a line underneath, and it goes this way. Okay. All right, lastly, distribute on that. -3x plus 6 is less than or equal to 24. Subtract 6 from both sides. -3x is less than or equal to 18. Divide by -3. Now be careful here because we're dividing by a negative. So x is flip the sign, greater than or equal to -6. Okay, so now -6, there's a line underneath the equal symbol or the greater than symbol, so we're going to fill it in. And since x is on the left, it points to the right, we're going this way. Okay? So, if any of that was too fast, pause the video, rewind, go back, watch it again, make sure you get it, make sure you understand why. Okay, so put the correct word phrase with the correct symbol. Okay, so what we're going to do is figure out which inequalities go with which. At most. So if I say I have at most $10, that means I probably have less than that, right? Or at most, I could potentially have that. So it's going to go with the less than or equal to, okay? Because I have at most a certain number. That one's done. At least, well, at most goes this way. At least has to be the opposite. I have at least usually goes with a greater than or equal to symbol. Maximum of. So this means I cannot have any more, right? It's got to be that. It's got to be that number or less. So I have a maximum of. Okay. I have a minimum of. Goes with the greater than. How about no more than? Okay, so if it says no more than 18, right? Then you can have 18. But you can't have anything more than that. Same thing here, no less than. Surprisingly, they all go in greater than or equal to or less than or equal to. Okay. Translate the verbal sentences into an algebraic inequality. X is at most 50. At most. So looking up here, at most is in the top right. So X is at most 50. It means we can have 50 or we can have less than that. How about the sum of 5x and 2x? So sum is positive. So 5x plus 2x is at least 70. So it has to be at least 70. It's bigger than 70 or equal to 70. And then the maximum value of 4x minus 6. Maximum is 54. So 54 is what it could be, or it has to be less than that, okay? All right, lastly, write an inequality and solve the problem algebraically. Joan needed $100 to buy a graphing calculator for her math class. Her neighbor will pay her $10 per hour, important piece of information, and her father gave her $25 for mowing the lawn. What is the minimum amount of hours she needed to babysit in order to buy her calculator? Okay, so we know it's $100, right? So we need to figure out, because she has to have at least $100, at least, to buy the calculator. She could end up making more, but she has to have at least that. So she has $10 per hour, and she starts with $25. Okay, so there's our equation. We're going to solve. Okay, so 10x is greater than or equal to 75. Divide by 10. X is greater than or equal to 7.5 hours. Okay, so that's the minimum number of hours that she can work. All right, how about the next one? Mr. Scott decided he would spend no more than $120, so less than or equal to $120 to buy a jacket and a skirt. If the price of the jacket was $20 more than 3 times the price of the skirt, find the highest possible price of the skirt. So the jacket is 20 more than 3 times the price of the skirt. I'm gonna use X for skirt here. Okay, well, it says find the highest possible price of the skirt. Okay, well, this is kind of, you're going to set up 2 here. You're going to do the jacket and the skirt, give you $120. But now I'm going to take this J, since it's equal to all of this, and I'm going to replace this in for that J. So I now have 20 plus 3x plus x is less than or equal to 120. So again, what did I do? I took this, because that's equal to J, and I plugged it in for this. Okay? So 20 plus 3x plus x is 20 plus 4x. It's less than or equal to 120, because you can combine these x's. And then I'm just going to solve. Divide by 4, x is less than or equal to 25. So the skirt is less than or equal to $25. Okay? All right, so you have an exit ticket. I want you to do the same thing. You're going to solve and then graph them. Remember, if the variable is on the left, you can just follow the sign. Okay? Translate these, so you're going to say x and 24, and you're going to put a sign in there, and continue on for the word problem. So if you have any questions, let me know. I will see you guys in class, and hopefully